Section 6.5 is titled Linear Inequalities. So first I want you to remember that if we had an equation that was an x equals some number, it was a vertical line, and if it was y equals some number, it was a horizontal line. And that will also be true for inequalities, so we could have x is greater than, x is less than, x is greater than or equal to, or x is less than or equal to some number, and it will still be a vertical line. Also with y, x is greater than, or excuse me, y is greater than, y is less than, y is greater than or equal to, or y is less than or equal to, those will also all still be horizontal lines. Also, when solving inequalities for a variable, remember that if you multiply or divide by a negative number, you must flip the inequality symbol. So let's look at some steps to graphing linear equalities. First, we want to graph the line. Just like if it were in slope-intercept form, we treat it like y equals mx plus b, even though the equal sign is now an inequality symbol. Or we can use the x and y intercepts if the inequality is in standard form. One difference between graphing lines and graphing inequalities is the style of the line. We'll graph a solid line or straight line if it's less than or equal to or greater than or equal to. But it will be a dotted line if it's just less than or greater than. Then we need to shade. Remember, with inequalities, we're talking about a large, infinite number of solutions, and that's where the shading comes into play. So we're going to pick a point that's clearly on one side of the line or the other. We're going to plug it into the inequality. If it makes the inequality true, then that side with the point is where we shade. But if it makes the inequality false, then the opposite side of where the point was gets shaded. And I know that sounds a little confusing, but it'll make perfect sense when we look at some examples. So let's do just that. Let's graph the inequality. This appears to be in slope-intercept form, y equals mx plus b, but yes, it is an inequality. So we still want to start at the y-intercept of -1. This is still our slope, the number in front of x, and it's positive 3 or 3 over 1. So we're going up 3 and to the right 1 so that we have positive slope. I'm also going to go down 3 and to the left. You do want to make sure that these get graphed all the way across the graph. So we want our line to stretch all the way across. But now we need to determine if we have a shaded line or a dotted line. So a solid line or a dotted line. So let's go back and look. The style of the line is determined by the symbol in the inequality. We have a greater than symbol, therefore we're going to graph a dotted line. So instead of graphing it straight through, we are going to dot it. And we do that because what this actually means when it's greater than or less than and we dot it, it means that our answers, the ordered pairs that make up this line are actually not included in the answer. But now we have to determine which way we're going to shade, because half of this graph is going to get shaded, either on this side or on this side. And we have to determine where that occurs. We do that by picking an ordered pair that's not on the line. Pick something relatively easy. Normally I would say pick 0, 0, but in this case it's kind of hard to tell if 0, 0, if our line goes through 0, 0. So I'm going to pick something over here. I'm going to pick this ordered pair, which is 4, 0. Remember, this is all just to determine which way we're going to shade. So if I pick 4, 0, we need to plug 4, 0 in for x and y, making sure that you're plugging the points in to the correct place. The 4 goes in for x, and the 0 goes in for y. Now we need to solve this equality and determine if this is a true statement or not. Is 0 greater than 11? Well, no, it's not. That means we need to shade not on the side of the line where the point was we picked, but on the opposite side. Since this was false, we want to shade opposite this point, so we're shading over here. That means that every ordered pair we are shading now is a solution to that inequality. So we graph the line just like we normally would graph a line. We determine if it's dotted or solid, and then we shade appropriately based on the ordered pair we pick. Could have picked any ordered pair. Let's look at number 2. We have y is greater than or equal to 1/2 x plus 1. So we're going to start at positive 1. Up 1 and over 2 in the positive direction, so our line has positive slope. Down 1 and over 2. To the left, our graph has positive slope still this way. Now we have to determine if it's a solid or dotted line, and you can see that the inequality has the line underneath it. That means it is solid. This dot should probably be up a little higher. There we go. But now we have to determine where the shading occurs. And again, I mentioned in the last slide, the easiest point to pick is 0, 0. So if we plug 0 in for y, and we plug 0 in for x, we get 0 is greater than 0 plus 1, greater than or equal to, or 0 is greater than or equal to 1. And the question is that true? Is 0 greater than or equal to 1? Well, no, it is not, which means we don't shade where 0, 0 is, we shade opposite or above that. So this instance we're shading above the line because the point we picked did not work in the inequality. So we don't want to shade here because this point didn't work. That means none of these other points would work either. So all the points on the opposite side of the line would work. If we had checked the point, let's say 0, 6, that should solve the inequality and be true. So should any other point that's up here in the shading. Let's look at an example like number 3. Here we have an inequality that looks to be in standard form, so let's use the intercepts. Remember how to find the intercept. The x-intercept is found by making y 0 and solving for x. So if I make y 0, that term goes away, and we get 6x is less than 12, or x is less than 2, and you can kind of treat this like an equal sign. Basically, 2 is the intercept on the x-axis for this inequality. Similar with the y-intercept, we want to make that x term 0, so this goes away, and we get 8y is less than 12. Divide both sides by 8, and we get that y is less than 1.5 or 1.5. So, and again, we treat this like an equal sign. This is your y-intercept, so it's going to be up here at 1.5. Now, do we want a dotted or solid line? We want a dotted line, and it's because we just have the less than symbol. And again, we want to make sure we extend this all the way across the graph because we have a lot of shading to do. And now we want to determine where we're going to shade. Well, I'm going to pick 0, 0 again. It's obvious that 0, 0, the line does not go through 0, 0. So that's the ordered pair I'm picking. If it solves the inequality and is true, then I'll shade down there. But if it's false, I need to shade opposite. So above or on this top side here. So if I plug in a 0 for x and a 0 for y, I get that 0 plus 0 is less than 12, or 0 is less than 12. And the question is that true? Yes, it is. This is the first yes we've had. Because it's true, I need to shade where that ordered pair is. So that was down here below the line. And sometimes I'll refer to the lines as being above or below. And hopefully that makes sense here. So now we've done 3 examples. If you'd like, you can try this one on your own. Remember, when an equation or an inequality is in standard form, you always have the option to solve it for y, or you can use intercepts. This one maybe is to use the expression 6 or 1/2 dozen the other, which means it's probably simple to do it either way. This equation is inequality is pretty easy to solve for x, or for y we just subtract to the other side. So we would graph up at positive 6. My slope is negative 1 or negative 1 over 1, so I'm going down 1 over 1 in the negative direction. Same thing, up 1 over 1 in the positive, or up 1 over 1 so that my line is still negative. And it's going to be a solid line because it's less than or equal to. Now notice where the intercepts were. If I had solved this equation finding the x-intercept, I would have plugged 0 in for y and gotten an x-intercept of 6. If I wanted to find the y-intercept, I would have plugged 0 in for x and gotten also a y-intercept of 6. So you can see that either way you graph, this is two different options, down here or above. But now I need to shade, and I shade based on the ordered pair I pick. I'm going to pick 0, 0 again. It's, again, the easiest point to pick. So if I plug in a 0 for x and a 0 for y, I get that 0 is less than or equal to 6. The question is that true? And yes, it is true. 0 is less than or equal to 6. So that means I'm shading everywhere below the line because that's where 0, 0 is in relationship to the line. Hopefully you were able to graph that one on your own using either the method where you solve for y or you use the intercepts. Then you were able to successfully pick a point, plug it in, see if it solved the inequality truthfully, and then shade properly. Here we have x is greater than 0. Remember from the second slide, if it's an x equals some number, it was a vertical line. That's still the case here, even though it's an inequality. So here, what we want to do is figure out where 0 is on the x-axis, and it's right here in the center. Is it going to be solid or dotted? Hopefully you're saying dotted. And it's a vertical line that goes through 0, which means it's the y-axis. And it's kind of hard to see this, but I've got it here in red, so hopefully you can see. But now we want to do some shading. And you can look at these a couple of different ways. This inequality says all of the x values that are greater than 0. Well, all you have to do here is look at your x-axis. We have the values on the right of the inequality graphed and the values on the left. Which ones are positive? Which ones are greater than 0? Well, all the ones on the right. So that means we would shade everywhere here. You also could pick an ordered pair. You cannot pick 0, 0 because the line goes through 0, 0. So you could pick something like, let's see if I can change colors so that you can see it. Let's pick 4, 2. Well, if I'm going to plug into the inequality, and the ordered pair is 4, 2 that I'm picking, the only thing I can plug in is the 4 for x. So I get 4 is greater than 0. That is true. So I shade over there where that green dot is. So you can actually pick a point, or you can think logically, what does that inequality mean? I think this might be our last graphing example, but we have x minus 2y is greater than or equal to negative 4. Again, you can use intercepts, or you could solve the equation for y. First, I'm going to do it with the intercepts. So I would plug in a 0 for y and get x is greater than or equal to negative 4, or my x-intercept is negative 4. For my y-intercept, I plug in a 0 for x, and I get negative 2y is greater than or equal to negative 4. I need to divide both sides by negative 2, and I get y. Technically, I should be flipping this symbol, but because it's an intercept, you can even treat these as equal signs. Negative 4 divided by negative 2 is a positive 2. So my y-intercept is a positive 2. So that's one method. Or you could solve this inequality for y. So we would subtract x to the other side. Negative 2y greater than or equal to negative x minus 4. Divide everything by negative 2. And we would get, again flipping the symbol, 1/2 x plus 2. So let's check that that still would work. If these are my intercepts, I start at positive 2, my slope is at positive 1/2, so I'm going up 1 over 2 in the positive direction. And now I'm going to go down 1 and over 2 so that my line still has positive slope. And this one I kind of keep missing, it looks like it's up here a little higher. But it is the exact same line. So you can do intercepts or you can solve for y. It's your choice. Sometimes I think intercepts are a little bit easier. There's a greater chance, I think, for an error when you're trying to solve an inequality for y. We have a solid line because we have the bar underneath it or greater than or equal to, so it's a solid line. And then we need to determine where to shade. I'm going to pick 0, 0 again. So when I plug 0, 0 in, I get 0 minus 2 times 0 greater than or equal to negative 4. So we get 0 is greater than or equal to negative 4. This is true. Be careful, this is a negative 4, so 0 is greater than negative 4. Which means we want to shade where 0, 0 is, which is below the line. So all of our shading is now below the line here. Now let's go the other way. Now we're given the graph and we want to write the inequality. And we're always going to do this in slope-intercept form because that's easiest. So we have y and mx plus b, and we need to fill in our symbol here, so we'll worry about what that is in a second. So my y-intercept is a negative 2, so it's going to be a minus 2. Y and x are my variables. And my slope, if I start here at my intercept, I go up 1, 2, 3, and over 1. Up 1, 2, 3 over 1, up 1, 2, 3 over 1. So it looks like it's a positive 3 or 3 over 1. Now I have to determine what kind of symbol I have. It is a dotted line, so it's either going to be greater than or less than. The question is, which one is it? And what we need to do is pick a point from the shaded region. And again, be careful that you're not picking something on the line, but pick something simple. So let's say 3, 0. So if I plug in 3, 0, and I solve this out, I get 0 on the left-hand side. I haven't put my symbol in here yet because I don't know what it's supposed to be. And I get 0 minus 2, which is a negative 2. Now, if that's where I shaded, I need this to be a true statement. So the question is this 0 less than negative 2, or is 0 greater than negative 2? You should be saying that 0 is greater than negative 2, so my symbol should be greater than. And I just realized that that's not the point I picked. I put a 3 in here instead, so that's going to change everything. So it's 9 minus 2, or 7. 9 minus 2 is 7. I want this to be true, so I actually need less than. 0 is less than 7. I apologize for that. So the symbol should be less than. I was stuck on picking 0, 0 because that's what I picked for so long. But here I picked a point in the shaded region because I know that I need that to be true. So plugging in the 3, 0, when I solve the right-hand side, I get positive 7, and I need 0 to be less than 7. I need this to be true, so again, it's less than. In class, we'll work on worksheet 6.5.